Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to understand theory plus practical of NAT. NAT is network address translation. As you know, it is a very important topic for network engineer. Interviewer is also asking lots of questions from this topic. So after watching this video, you don't need to watch any other video on NATing. In this video, we are going to discuss each and everything. Like here in this topology, first of all, let me make you familiar with this topology, guys. Here you can see I have one internet router. This is internet router, and I have two edge router R1 and R2. These are two edge router of my company, let's say. Right here we have some LAN user, but in my company this is network of my company. In my company there are three VLAN: VLAN 10, VLAN 20, and VLAN 30. As you can see here, we will configure VLAN as well. Right, on switch we will configure SVI on, not SVI, inter VLAN routing. I will use router on a stick method for the inter VLAN routing. Right, I will configure virtual interface on router number 1. After that, these LAN user means LAN user of VLAN 10, LAN user of VLAN 20, or LAN user of VLAN 30 should be able to access internet 8.8.8.8. And as you know, by default router 1 don't know about 8.8.8, because like 8.8.8 there are million of network, right, on internet, on internet router. Million of network is connected with internet router, so it is not possible to configure million of network in the routing table of router 1. So instead of configuring each individual route in the routing table of router 1, we will configure one default route towards ISP. Here we will configure one default route 0.0.0 towards internet, toward, let's say, ISP on both router, on this router also, on R1 as well as on R2. Here also we will configure one default route 0.0.0 towards ISP. We will configure one default route on R1, one default route on R2. After that, here we need translation, because if we will forward traffic directly, let's say PC from which VLAN, let's say from VLAN 10 want to ping 8.8.8. So if this PC want to ping 8.8.8, source IP will be the IP address of this PC. IP address of this PC is 192.168.10.1, and destination IP address will be 8.8.8.8, because this PC want to ping 8.8.8.8. So if source is the IP address of PC and destination is 8.8.8, there is one default route available in the routing table of router 1. So router 1 will forward the traffic to internet, but internet router will not forward the reply, because internet router don't know about the private network, or your private network is not routable on internet. So these IP address which you are running in the private network is not routable on internet, so we cannot forward traffic on internet with the help of my private IP address. So here we will configure what NAT on router number 1 also, and on router number 2 also. Okay, so what is NAT? In the simple word, NAT is an technology, or NAT is a process which is used to make communication possible between private and public network. So R1 and R2 should be responsible to translate the private IP address into public IP address whenever it will receive traffic on the private interface. Let's say PC1 is forwarding a traffic again, right, with source IP address same 192.168.10.100, and destination IP address is 8.8.8.8. Where router 1 will receive this traffic, router will translate the source IP address, because source is the private IP address and private IP address is not reachable on internet. So it will translate source 192.168.10.100 or 1 into the public IP address 1.1.1.1. And when again reply will come back, it will translate the 1.1.1 into your private IP address, that is 192.168.10.100 or 1. Like this NAT will work on router number 1. Okay, so here just I am not going to configure netting only. So we have multiple VLAN. That's why, this is a real time scenario. In real time, we have multiple VLAN in my company. So you will understand how to configure NAT when we have multiple VLAN in my organization. We are going to configure everything step by step. Till now I have not configured the IP address also on the router. Okay, first of all, let me introduce you to one file where I have mentioned about NAT, about network address translation. So let me open that. Here it is. So here also you can read. I will, guys, if you need this file, I can give you this file in the description. You can download. NAT stands for network address translation, and it is a process or technology which is used to make communication possible between private and public network. By default, private and public network cannot communicate with each other. As you know, public network means this network 1.1.1 or 8.8.8.8, which is available on internet router. So, and these are the private network. So private and public by default communication is not possible. So NAT is a technology which is responsible to make it possible. It primarily used to allow multiple devices on a private network such as home or office network to share a single public IP address when communicate with device on the internet. So whenever a private user want to communicate with a device on internet, NAT play a very big role, right? So it allowed to use a single public IP address. Then after that, how NAT works. So see guys, how NATs work. First of all, private IP address. What is private IP address? As you know, from each class we have one range of private IP address. Private IP address are reserved for use within private networks and not routable on the internet. These addresses are defined in RFC 1918 and include the range like, from class A, the private IP address is reserved this range 10.0.0.0/8. From class B, private IP address is reserved from this range 172.16.0.0/12. So till this bit 12 bits is reserved for private IP address, 8 bits is reserved for public private IP address in class A, 12 bits is reserved in class B, and 16 bits is reserved in class C 192.168.0.0/16. So these are the range of private IP address in each class. And as you know, these addresses are not routable on internet. That means we can use this address in private network only. After that, what is public IP address? Now public IP address are those address which we can assign to the internet. So a public IP address is assigned to a network by an internet service provider and used to identify a network on the internet. Very good. It is used to identify network over internet. After that, NAT device. What NAT device will do? So a NAT device typically it can be a router. A NAT device can be a router or it can be a firewall. So see, sits between private and public network. So it is router and firewall, means NAT device, where you will place NAT device between private and public network, sits between private and public internet network. It has a private IP address on the local network and a public IP address on the internet facing side. Like in my topology, as you can see, router number 1 have one interface in private, like this interface is connected with private network and this interface is connected with public network. So this is my NAT device. Router 1 is my NAT device. So I have placed router 1 between public network and the private network. This is my private network. This is my public network. So between private and public, you will place the NAT device, and NAT device can be your router or can be your firewall. See, interviewer can ask you this type of question in interview. So please guys, be prepare yourself for the interview as well. Okay, so it has a both private as well as public IP address. Private IP address on the local networks local interface side or private interface, and public IP address on the public internet interface. After that, translation table. So network address translation device, NAT device, maintain a translation table for the translation. The NAT device maintain a translation table to keep track of each mapping between private addresses and their corresponding public IP addresses. So whatever private IP address will be translated into public IP addresses, that NAT device will store in their NAT table. So all NAT device maintain one NAT table where it store the translated addresses. Okay. Now, outgoing traffic means the reply traffic. So this is fine that whenever router, let's say this PC from VLAN 10 want to send some traffic to internet. This PC want to send some traffic to internet. So it will forward traffic to router number 1. First router will maintain one NAT table. In NAT table they will make one entry that I have translated which IP address? Private IP address, that is 192.168. Let's say 10.1 into what public IP address? Into 1.1.1.1, right? And when reply will come, see, for the outgoing traffic, when reply will come, source IP will be what? In the reply, the IP address of internet router, and destination will be 8.8.8, because now traffic, who is forwarding traffic? 1.1.1. In the new traffic, after the translation, source IP will be 1.1.1.1 and destination IP will be 8.8.8.8. When internet will generate reply, source will be 8.8.8.8 and destination will be what? 1.1.1.1. So it is forwarding traffic to 1.1.1, right? So again, your router, when it will receive the reply, it will translate what? Destination IP address. This time destination is public, so it will translate public IP address into the private IP address. So here also we are talking about the outgoing traffic. Outgoing traffic means when a device on the private network initiate communication with a device on the internet, the NAT device replace the source IP address of the outgoing packet with their own public IP address and adds an entry in the translation table to remember the mapping. Okay, it is very clear. After that, incoming traffic, when reply will come, when response packet arrive at the NAT device from the internet, it checks the destination IP address and port, then consults the translation table to determine the private IP address and the port number to which packet should be forwarded, and then the NAT device modify the destination IP address and port of the incoming packet accordingly and forward it to the appropriate device on the private network. This is very clear. Definitely, whenever the NAT device will receive a traffic from the LAN network, from the LAN user, it will make one entry in the translation table. After that, it will forward, it will translate source IP address into public IP address and it will forward to internet. When reply will come, it will check the destination and NAT table, and after that, according to the translation, it will translate the destination public IP address into private destination address, and then it will forward from the LAN interface. It is very clear here. After that, port mapping. To handle multiple devices on the private network, the NAT device also modify the source port number of outgoing packet and maintain port mapping in the translation table. This allow multiple devices to share same public IP address by using different source port number, right? So multiple private IP address can be translated into a single public IP address with the help of port mapping, and that is nothing but PAT, port address translation. As you know, we have three types of NAT: static NAT, dynamic NAT, and PAT. In PAT, we translate port number, source port and destination port. On the basis of port number, NAT device will perform translation. Okay, by using NAT, a private network can convert public IP address and provide a certain level of security by hiding the internal IP addresses from the internet. Definitely, on the internet, your private IP address is hidden, right? Because router have already changed the source IP address. It acts as an intermediary that manage the translation of IP addresses and port number between private network and the public internet. Now, types of network. So we have three types of network address translation, NAT. First is static. Static is nothing but one-to-one translation. In a static NAT device translate one private IP address into a single public IP address. Always, like in this topology here, you can see this side. I have designed this topology. You know why? Because see here we have only one server. In this network we have only one server. So here we need to configure a static NAT, because I need to translate only one private IP address into public IP address. But in this network, we have multiple user. Maybe there are 100 user in VLAN 10, 120, 130. But in this site, I have only one device. And always keep in mind, whenever you have a server in your network and you want to give the access to that server to outside user, you will configure a static NAT. Right here, these user like VPC6 can access this server with the help of public IP address, with the help of public IP address of this server, because here we are going to configure the static NAT. Don't worry, I will show you each and everything step by step configuration as well, guys. Here we will configure a static NAT, and after configuring a static NAT, anyone from outside, from the internet, can access this server with the help of public IP address, with the help of public IP address. So I can hide my private IP address as well over here. Okay, done. Now let me move further. Okay, first one is static NAT, and it is one-to-one mapping established between a private IP address and a public IP address, a single private IP address and single public IP address. It allows for a fixed and permanent translation of IP addresses. A static NAT is often used when a server on a private network need to be accessible from the internet using a specific public IP address. As I told you, that whenever you want that your server should be accessible by outside user on the internet through the public IP address, in that scenario we need to configure a static NAT. And a static NAT, guys, is very important. We are still using this static NAT in real time nowadays. Okay, after that, second type of NAT is dynamic NAT. In dynamic NAT, what we can do, we can create a pool of public IP address. See, dynamic NAT allow for a pool of public IP addresses to be shared among devices in the private network. The NAT device dynamically select a available public IP address from the pool and assign to its internal device when it need to communicate with the internet. Let's say in this topology here on router number 1, I have created one pool. What I can do, I can create one pool of public IP address. Let's say 1.1.1.1. In the pool there are, let's say, 4 IP address: 1.1.1.2, 1.2, 1.1.1.3, and 1.1.1.4. How many IP address we have in the pool? We have 4 IP address in the pool. Now this router can choose any one IP address, any one public IP address for the translation. Let's say router 1 have used this IP address, means this IP address is now translated into one public IP address, that is let's say 192.168.10.1. After that, second user is requesting for a traffic to internet, so it will use second IP address 192.168.10.2. 10.2 is translated into this public IP address 1.1.1.2. After that, still we have 2 free IP address in the pool. So let's say third user is also requesting for sending a traffic towards internet, so it will translate source this 192.168. let's say 10.3 into 1.1.3. Then fourth user is also sending traffic to internet, so it will translate 192.168.10.4 into 1.1.4. Now if fifth user will try to send traffic to internet, router cannot perform translation because in the pool there are only 4 available IP address. So at a time only 4 user can access internet. Not more than 4 user can access internet at the time. Let's say router 1 have received the reply. So now this IP address is free. Now it can send the traffic. User 5 192.168.10.5. Like this dynamic NAT works. So in dynamic NATs, suppose we have 4 number of IP addresses in the pool. That means only 4 user can access internet at the time. This is the disadvantage of dynamic NAT. And to be honest guys, nowadays we are not using dynamic NAT. We are using a static NAT and PAT directly. We are not using the static NAT. Okay. So let's understand the PAT now. PAT is nothing but the overloading NAT. What we called it, overloading NAT, or we can say port address translation, or in the short you can say PAT. Overlapping NAT, also known as port address translation, is a variation of dynamic NAT. It is definitely variation of dynamic NAT where multiple private IP addresses are mapped to a single public IP address by using the different source port number. Getting my point? Here by using the source port number, it can use a single public IP address for the translation of multiple private IP address. The NAT device maintain a translation table that include the source IP address, source port address, destination IP address, and destination port address. Now in overloading, NAT device maintain NAT table where it will keep information of source IP, destination IP, source port, and destination port. On the basis of port number, PAT will perform translation. So this allow multiple device on a private network to share a single public IP address. Now here we don't need to create the pool of IP addresses. So I am not going to configure guys dynamic NAT. Directly I am going to configure static NAT over here and PAT over here. Port address translation in this domain. Here we will configure PAT inside my network. In this network we will configure PAT, and here we will configure a static NAT. And these two are the types of NAT which nowadays we are using. Now guys, we have some John in NAT, so let's discuss Johns as well. So Johns means, as you know, area. So in NAT network address translation terms, inside John, outside John, inside local, and inside global. We have only 4 John in NAT. Inside John, outside John, inside local, and inside global, okay, are used to describe different elements and IP addresses involved in the translation process. Let's understand what is inside John. So like here in the topology, inside John means guys your private network. Your private network. This is nothing but the inside John. Outside John means nothing but your remote private network, like this network. Suppose VLAN 10 user, this user want to send some traffic to this server. So this server is outside. This server is in outside John. So it will consider the destination as outside John. Or let's say this server is a server of Google. Okay. So here also you can read the inside John. Where is inside John? Here it is. This inside John refer to the internal network or private network where the devices using private IP addresses are located. It includes computer, server, and other devices within the private network. So this is nothing but your private network. It is very clear with the name also. Inside John represent the network that is being translated by the NAT device. Definitely these are the devices whose IP address need to translate on router number 1. Okay. After that, outside John. So outside John refer to the external network. right? External network, typically the internet or where device and system outside the private network reside. Okay, the outside zone represent the network to which the inside zone communicate or connect. So like here, suppose if you want to ping 8.8.8.8 from PC of VLAN 10 user, from this PC, let's say you want to ping 8.8.8. So 8.8.8 is outside and 192.168.10.1 is your inside, like this. Okay. After that, we have some more zone inside local zone. So inside local zone refer the private IP addresses and port number to the device within the inside zone. It is the IP addresses and port used by the device within the private network before the translation occur inside. I will make you understand these things while configuration as well. Inside local addresses are typically not routable on the public network. Inside global is your public network. Inside global is your public network. Inside global refer to the public network. Now inside global in the topology is this one, this network. This is your public network between R1 and ISP. Done, guys. Now I am going to start the configuration. First of all, I am going to configure the IP address on router. So let me take you to router number 1. Let me save this file somewhere so that I can upload this file while uploading video in the description for you guys. Let me save it in download and say NAT file. Okay, done. After that, on router number 1, first of all I am going to configure the IP address. So I have access of router 1 here. Enable config t. Hope this configuration is visible, the text is visible. Here host name is R1 and interface F0/0. This is the WAN interface. Here I am going to say description connected to internet. I am configuring like real time. Okay, so this is how we configure these things in real time. Description connected to internet. After that, no shutdown, and then IP address is 1.1.1.1. 255.255.255.0 is the subnet mask. Done. Exit. Interface F1/0. No shut. Description connected to switch. Connected to switch, and I have run no shut command now here, and here I don't need to configure IP address, so say no IP address over here. Exit. Interface F0/0.10, because here you know we have multiple VLAN, so we need to create sub interface over here. So interface VLAN interface F0/0.10. Description connected to VLAN 10. Connected to VLAN 10. After that, encapsulation protocol. Encapsulation protocol is .1q for VLAN 10, and IP address over here is 192.168.10.100. 255.255.255.0. Exit. Interface F1/0.20. Description connected to VLAN 20. VLAN 20. Encapsulation protocol is .1q for VLAN 20, and IP address is 192.168.20.100. 255.255.255.0. Done. Interface F1/0.30 for VLAN 30. Description connected to VLAN 30. Encapsulation protocol is encapsulation protocol .1q for VLAN 30, and here IP address is 192.168.10.30. 10.1 30.100. Sorry. subnet mask 255.255.255.0. I've configured the IP address on all interface of router number 1. Let me save the configuration, copy, running configuration, or directly we can say do write. I've saved the configuration. Now let me configure IP address on internet router. So where is my internet router? R2. First of all, let me configure IP on R2. Okay. Config T, hostname R2, interface F0/0. This interface description connected to WAN or internet, and IP address is 2.2.2.1 255.255.255.0 and say no shutdown. Done. Exit interface F1/0. Say no shut over here as well, and description connected to switch, and IP address is 192.168.100.100. let's say 255.255.255.0. Done, guys. Say no shut as well. I think I have already run no shut command. Exit and write. If you want to verify the IP, show IP interface brief exclude unassign. Now you can see line protocol and status both are up of these two interface. On router number 1 also, let me verify IP address once. If you want to verify the IP configuration of router 1 also, you can verify by running command show IP interface brief exclude unassign. Here also you can see I have configured these IP address on interfaces. Okay, so configuration, IP configuration is perfect. Now I am going to configure IP on internet router. So here I have internet router. I think this is router 2. This is router 2. I have 2 times I think router 2. This is router 2. Okay, let me take access of internet. Say no. And on internet router, I will configure only IP address, right? I will not configure anything else on internet router. Okay, guys. After configuring IP address, I am going to make you understand all configuration step by step. Don't worry. On internet router, first of all, let me configure the IP interface. Loopback 1. First of all, I am going to create the loopback. IP address is 8.8.8.8 255.255.255.0. So I have configured the IP address on loopback interface. Now interface F0/0 no shut, and here we can define the description connected to let's say R1. I have defined anything, any description you can put. Then IP address 1.1.1.2 255.255.255.0. Exit interface F1/0 no shutdown, and here IP address will be what 2.2.2.2 2.2.2.2 255.255.255.0. Done. So IP interface brief exclude unassign. So IP interface brief exclude unassign. Done. IP configuration on internet router is done. Now I am going to close this. Okay. Now let me configure VLAN on switch. Enable config T VLAN 10 exit, VLAN 20 exit, and VLAN 30 exit. I have created 3 number of VLAN over here. Now interface E0/1. This interface is member of VLAN 10. Switch port access VLAN 10 exit, interface E0/2. Switch port access VLAN 20, exit interface E0/3. This interface is member of VLAN 30. So switch port access VLAN 30. Done. So VLAN brief. You can see. Done, guys. And this interface should be trunk, as you know, 0/0. So let me configure this interface as trunk as well. Interface E0/0. Encapsulation or description connected to R1, right? And here switch port trunk encapsulation dot 1q. Let me define the encapsulation protocol first on the trunk link, and then switch port mode trunk. So I have configured the link as trunk. You can verify by running command show interface trunk. So you can see E0/0 is your trunk link. Done, guys. Now let me configure the IP address to VPC. So let me configure one IP address over here. This PC is in VLAN 10. So IP address over here will be 192.168.10.1/24, and gateway is 192.168.10.100. Done. I've defined the IP address over here. Let me check that this machine is able to ping their default gateway or not. Ping 192.168.10.100. It should ping their default gateway. Let me check. It's not pinging. It's not pinging. So let me verify. I have to verify it, that why this machine is not able to ping. So this IP address is fine over here. Okay. And VLAN is also fine. 192.168.10.10 is fine. Let me check the IP address of this machine once. So IP address is 192.168.10.1. Perfect. This is the default gateway. Let me verify on switch. So VLAN brief. So this interface 0/1 is in VLAN 10, as you can see. Okay, this is also fine. So interface trunk. This interface is configured as trunk as well. Then why PC is not able to ping? What message I am getting over here? Let me maximize it. And discovery stopped behind discovery configuration wizard. No, this is different thing. This PC should ping. Let me try to ping the same IP address from the router number 1. Ping 192.168.10.10.100. Yes, I am able to ping it from router number 1. Let me ping once more time, guys. Let me check that maybe it was taking some time. No, it's not pinging. So ARP table is also entry. That means this machine is not able to resolve the ARP. So it is forwarding the ARP request. That will be the broadcast. ARP request will be received. Okay, everything is perfect over here. Let me check one more thing, the encapsulation protocol on router number 1. So run section. So run directly, we can say interface f1/0.10. So run interface f1/0. This interface is up or down. Description, no IP address, full duplex. And so interface or IP interface. So IP interface f1/0 line protocol of this interface is up. Internet protocol processing is disabled. Let me do one thing. Interface f1/0, say IP address. So I need to troubleshoot it directly. What I am going to do, I am going to check the running configuration of this router, let's say. So run In the running configuration, guys, of VLAN interface F0/0.10 connected to VLAN 10. See the benefit of description, right? And encapsulation protocol is 10. IP address is this one. Okay, here we have one problem. See, encapsulation, the interface fast Ethernet not 0/0. It should be F1/0. Here interface is right. For VLAN 30 also I think interface is right, but for VLAN 10 interface is wrong. So I am going to remove it, and IP address on this interface is also I am going to remove these things. So let me do one thing. Interface F1/0, no IP address, and interface F1/0.10. And first of all, I have to remove the IP address, otherwise it will overlap 0/0.10, and say no IP address over here first. IP address, and then interface F1/0.10 and description connected to VLAN 10 to VLAN 10, and then encapsulation protocol is encapsulation protocol.1q for VLAN 10, and IP address is 192.168.10.100 255.255.255.0. Now it should work. Let me check that still VPC means user from VLAN 10 is not able to ping. Now you can see it is able to ping, right? And you can verify the ARP table. So ARP. Now there is one entry. The MAC address of 10.1.1.100. Sorry, 192.168.10.100 means default gateway. Okay. So VPC means user from VLAN 10 are able to ping their default gateway. In the same way, user from VLAN 20 should be also able to access their default gateway. This is VLAN in VLAN 30 user. So here IP address is 192.168.30.1/24 and gateway is 192.168.30.100. Let me check that this user is able to ping their gateway or not. So ping 192.168.30.100. Okay, 30.100. Why it's not working? See, again I need to troubleshoot. Now this machine is not able to ping, so IP address is 192.168.30.1, gateway is 30.100. It's fine. Then why this machine is not able to ping? Let me ping one more time. No, it's not working. So ARP table is entry. Again it is not able to resolve the MAC address table. Don't worry guys, this is troubleshooting. At the same time you need to learn troubleshooting as well. So see how I will troubleshoot. So VLAN brief. First of all, I am going to check that this interface is member of which VLAN. See, this interface is member of which VLAN? VLAN 20. But this interface should be member of VLAN 30, and this interface should be member of VLAN 20. So I am going to correct it. I have configured wrong VLAN here. Interface F, not F, E 0/2. Switch port access VLAN 30. VLAN 30. And here if you want to define the description, so you can say description connected to VLAN 30 users. Like this you can define the description. After that, interface E0/3, and this interface switch port access VLAN 20. This interface is in VLAN 20. Now let me check that VLAN 30 user is able to ping. Now you can see it is able to ping, right? Now it's working fine. Let me check the ARP table. ARP table is also fine. Now I am going to define IP to VLAN 20 user. So VLAN 20 user will get IP from 192.168.20.0 network. So IP is 20.1/24 and gateway is 192.168.20.100. Done. Now this user should be able to ping their default gateway 192.168.20.100. and it's pinging. Okay, so all users are able to ping their default gateway. Now the second thing after configuring IP address is you need to configure one default route on your edge router. So we will configure one default route on router number 1 over here and one default route on router number 2. Okay, so let me do that. Let me take you to router number 1, guys. Here IP root, and as you know, default route configuration is very simple: 0.0.0 IP root 0.0.0 0.0.0. Exit interface is F0/0 and next hop IP address is 1.1.2. Done. In the same way, I need to configure one default route on router number 2 also. So let me take you to router 2. Enable config T IP root 0.0.0 0.0.0. Exit interface is F0/0 and next hop IP address is 2.2.2. Right now I can ping 8.8.8 from router number 1 or router number 2. Let me show you. See, from router number 1, if you want to ping 8.8.8, it will work because there is one default route, right? So when I am pinging 8.8.8, source will be 1.1.1 and destination will be 8.8.8. When it will reach to internet router will generate reply for 1.1.1 because 1.1.1.0 network is reachable from internet. But if I will ping same IP address 8.8.8 from my LAN interface, let's say from source 192.168.10.100, if I am pinging from this interface, it will not work. So here we need what? Translation. First of all, I am going to configure a static NAT translation on router number 2, right? On this router, I am going to configure the NAT, a static NAT. See, to configure a static NAT, just you need to follow some command on router number 2 directly. Do ping 8.8.8.8. Now you can see you are able to ping 8.8.8, but you cannot ping 8.8.8 from your LAN interface. Do ping 8.8.8 and source is 192.168.100.100. Right? See, it's not working from LAN interface because internet don't have this time. I am pinging 8.8.8 from this IP address. So source will be this. Source IP address will be this one and destination IP will be 8.8.8.8. But when it will reach to internet, so when internet will generate reply, destination IP address will be this one, 192.168.10.100.100, and there is no any route available for this network in the routing table of internet. So internet will discard it. Internet is actually discarding it. Right now I am going to configure the NAT. See, to configure a static NAT, command is very simple: IP NAT static, IP NAT, and then put question mark over here. You know, first of all, before configuring NAT, you need to define inside and outside interface of router. First of all, let me do that. Actually, I need to tell to router that which one is your inside interface and which one is your outside interface. Like on router number 2, see, F0/0 is outside interface, so I will tell to router IP NAT outside. This is your outside interface. Then exit interface F1/0. This is IP NAT inside. IP NAT inside. This is your inside interface, right? And after that, IP NAT, or if you want to verify, do so run section NAT, IP NAT. You can check how many command I have run in NAT. Just you have run IP NAT outside, IP NAT inside, and now you are going to run third command, IP NAT inside. Then source static. Source is static. Then please tell me the IP address of IP address which you want to translate. So IP address is 192.168.10.100.1. This is the IP address, static IP address. After that, inside global IP address, what is the public IP address? To which address you want to translate this address? 2.2.2.1. I want to translate this IP address into this IP address. Yes or no? Enter. That's it. This is the configuration. That's it. Now I can ping 8.8.8. This user means server can ping 8.8.8. Let me show you. Let me take access of server. Here I am going to define one IP address. IP is 192.168.100.1/24 and gateway is 192.168.100.100. This. First of all, let me check I am able to ping my gateway or not. Ping 192.168.100.100. Yes, I am able to ping my gateway. That means I am able to ping internet as well. It can ping 8.8.8 as well. Let me show you. Ping 8.8.8.8. See, it's working. Yes or no? And on router number 2, you can verify the NAT table. On router number 2, let me run command. Show IP NAT translation. You can see the translation. Means this IP address 192.168.10.1 is translated into 2.2.2.1, right? Destination is always what? 8.8.8, and this is inside global. Inside global means your public network 2.2.2. Inside local means your private network. Outside local means remote network, and outside global means also what? Remote network. Done. So this is the NAT table, translation table, which this router is maintaining, and it will always translate this IP address into this IP address. So whenever this router R2 will receive any traffic where destination is 192.168.100.1, it will translate that IP address into 192.168.10.100.1 into this private IP address. Let's say someone is sending traffic to this IP address to 2.2.2.1. It will automatically translate 2.2.2.1 into this IP address. Let's say on ISP router, if I will ping, or let me do one thing. What I am going to do, let me take access of ISP router. From internet router, I am just going to ping public IP address, ping 2.2.2.1. Guys, I am not pinging the IP address of router interface. See, it is pinging the server IP address. It is pinging the server IP address. You know how, if you want to verify, you can clear IP NAT translation. After that question mark, here we can say, let's say inside, outside, inside, then question mark, and here we need to define the IP address. Okay, leave. So IP NAT translation. See, there is one translation that 1.1.1.2.2.2.1 2.2.2.1 is the translated into this IP address. And see the outside global address, someone have requested from this IP address. This is the IP address of ISP, yes or no? And see, this IP address is translated into this private IP address. So when someone will hit 2.2.2.1 on router number 2 on F0/0 of router number 2, that is outside interface, it will translate directly without thinking anything, right? It will translate the traffic to 192.168.100.1 and it will forward to server. Okay guys, okay, hope now till here everything is okay. Now on router number 1, I am going to configure PAT, port address translation. Guys, to configure port address translation, PAT or dynamic NAT, first of all we need to configure access control list. Access control list, or we can say IP access list. Access list standard and number is, let's say, 10. And then we need to match the private network. So my private network is permit 192.168.10.0 or VLAN 10. So I have allowed this traffic. Just I am using access control list for classification of traffic, not for filtering the traffic. Here I am making interesting to this traffic. So I have permit this traffic in access control list 10. I am going to allow the 192.168.20.0 also. VLAN 20 user are from this network, and VLAN 30 user are from 192.168.30.0 network, from this network. So I have created the access control list. In access control list there are 3 match. Yes or no? Now we need to enable NATing, and as you know, before enabling NATing we need to define inside and outside interface. So say interface F0/0, IPNAT outside, exit, interface F1/0, IPNAT inside. Done. And now IP NAT inside source. This time source is not static. Source is match source from list number 10, from access list 10, and destination will be interface F0/0 IP address. And then you need to use one keyword, that is overload, for the path. That's it. So IP NAT translation. Now there is no any entry in the translation table, and I can ping 8.8.8 from my LAN interface. Ping 8.8.8.8, and source is 192.168.10. Let's say 100. So IP NAT translation. So run section IP NAT inside source list 10 interface F0/0 overload, everything is fine inside outside. So run interface F0/0. You know, this interface is your inside interface, but you have created the virtual interface over here. Interface F1/0.10, IP NAT inside, exit, interface F1/0.20, and IP NAT inside, interface F1/0.30, and IP NAT inside. That's it. Now ping 8.8.8 and source 192.168.10.100. Let me give me. Now you can see the PC ping 8.8.8.8 and source fast Ethernet 1/0.10. Means from my LAN interface I am able to ping, or like this also you can ping 8.8.8.8, and source is 192.168.10.100. You can see, and check the PCs are able to ping or not. So let me take you to any PC. From here ping 8.8.8.8. VLAN 30 user are able to ping 8.8.8. All VLAN users are able to ping 8.8.8. You can verify. Ping 8.8.8.8. And these user can access the outside server as well, guys. If you want to verify, see, ping 2.2.2.1. Through this IP address it is able to ping the server. This is the public IP address of server. Actually I am not pinging the router interface, I am pinging the server, right? Because whenever router 2 will receive the traffic where destination is 2.2.2.1, it will translate the destination into 192.168.100.1, because there is one static translation. So outside user can access this server with the help of public IP address. Any server, any PC ping 8.8.8, it is able to ping 8.8.8, and it can access the server as well. by pinging the public IP address of server. This is the public IP address of server. Done. So that's all for today, guys. If you have learned something from this video, please hit on like button. If you have not subscribed this channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. See you in next video.